Alright, so let's practice graphing some polynomial functions. So I have a function right here, f of x equals x plus 2 times x plus 1 squared times 2x minus 3. Well, I know it's a polynomial function, so let's find out what is the degree. So the degree is, okay, how do we determine the degree? I have an x in here, and then it's going to be times another x, so that's an x squared. But then this one is squared, so this is actually x squared. So I have x times x squared, that's x to the third, and then times a 2x, that's x to the fourth. So the degree is 4. And then what is the leading term? The leading term is going to be x times an x squared from here times a 2x. So an x times an x squared times a 2x. So the leading term is going to be 2x to the fourth. So I don't care to FOIL all of this to get the information I need. All I need is the leading term, because the leading term is going to give me the end behavior. So to graph, what I'm going to do to graph is I know that this is giving me the end behavior. So the end behavior 2x to the fourth. I know 2x to the fourth is it's going to be like this, right? So it comes like this. So the leading term is positive, so it's going to start from here and then come down and then come back up. So the end behavior, how we're gonna write this to keep in mind is like it's gonna come from here, it's gonna do stuff in here. I don't know exactly what it's doing stuff in here, and it's gonna come up there. So in other words, the end behavior is x goes to infinity, the y goes to infinity, and as x goes to negative infinity, the y goes to negative infinity. Alright, because it looks like this. So I just put the arrow, I'm just kind of saying that it comes from up here and then it's going to do stuff and then it's going to end up here again. So both up on the left, up on the right. So this is going to allow me to draw my graph. Alright, so what are the zeros now? The zeros with their multiplicity, So the first zero is x equals negative 2, x equals negative 1 with multiplicity 2, and then from the last one, x equals 3/2. Okay, so we have, so it's gonna, this one is multiplicity 1, so it's straight up gonna cross. If it's multiplicity 2, that's an even multiplicity. So if it's an even multiplicity, it's going to touch just like that. So it's either going to touch like that or touch like that. So let's make a note right here. So it's either going to touch like this or touch like that. And then for this one, the multiplicity is 1. So it's straight up going to cross. So now we have pretty much all the information we need. So I know that the end behavior is like this. So that means that my graph is going to start in this quadrant, coming from up, and then it's going to have to end up in this quadrant. So basically, and then it's going to cross at negative 2. So negative 2. Okay, so that my graph comes from here. It's going to cross at negative 2. And then at negative 1, it has to touch. So at negative 1, here's negative 1 right here. I have to come back and touch. I can't touch like this because that means I have to come cross, but there's not a 0 between negative 2 and negative 1. So from the fact that -1 has multiplicity 2, basically this is the case I'm in. It's going to have to cross and touch like that. And then at 3/2 is going to have to cross. So if this is 1, this is 2, 1.5 is here. So it's going to have to cross, straight up cross in here. So from here, all it has left to do is cross in here and then go and end up. So it's going to cross and then end up like that. And if we don't have to be exact with how, well, in calculus you can be exact, but we don't have to be exact where the turning points are happening. So how many turning points do we have? 1, 2, 3. Okay, 3 turning points. So that means that the degree of this, it's at least 4. Well, I know that the degree of it is 4. So that's good that our graph has 3 turning points. So it has a local min in here, a local max, and then another local min in here. So there you go. This is the graph of f of x. So we used the end behavior. This told us that our graph starts here and ends here. And then the zeros are going to tell us exactly where to cross and how to cross, or how to just touch. All right, so let's do more. So graph this function. All right, so first of all, let's see what is the degree of it. So I have an x squared, and then I have an x cubed from here. So this is going to be an x to the 5th times another x, so it's going to be x to the 6th. So the degree is 6. Then what is the leading term? Because the leading term is going to give us the end behavior. So the leading term, well, I have a negative, so it's going to be a negative x squared from here, negative x squared, times I have an x cubed from here, and then times another x. So it's going to be negative x to the 2 plus 3 plus 1 6th. So the leading term is negative x to the 6th. So that means that it's going to behave like negative x to the 6th. And x to the 6th is basically going to be like x to the 4th, but even flatter at the origin. But the key point for x to the 6th for this one is that the coefficient is negative. So we have to flip this over the x-axis. So negative x to the 6th is going to be something like this. So more flatter and like this. So this is negative x to the 6th. So basically, what's the end behavior? Well, it looks like it's going to start from down below in here, and then whatever it's doing, so it's going to start here, and then it's going to end here. So in other words, as x goes to infinity, the y goes to negative infinity, and as x goes to negative infinity, the y goes down as well. So this is the end behavior. So this is going to tell us that when we try to graph this function, we're going to start from somewhere here, and then it's going to do stuff in here, and then it's going to have to end up in here. Okay, so this is important. Let's see what are the zeros now with their multiplicity, zeros. So I have -1, so x equals -1 with multiplicity 2. And then I have x equals 1 with multiplicity 3. And then x equals 2 with multiplicity 1. So for multiplicity 1 is going to straight up cross. For multiplicity 3 is going to be So that's odd with m equals 3 is odd, m greater than 1. So it's going to be either like this or like that. So with multiplicity 3 is going to be either like this or like that. And then with multiplicity 2, we saw before that it's going to touch either from down below or from up above. Okay, well, now my graph looks, let's see. So I have to start here, and then the first thing I have to do is cross, let's see, let me put my zeros. So x equals -1, x equals 1, and x equals 2. So at -1, what is happening at -1? At -1, the multiplicity is even, and it has to come from down here. So the only choice I have is to touch like this. I can't cross and then touch like that, because that means there would be another 0 less than -1, but that's not the case. So this is forcing me, if I have to start here and at -1 I have to touch like this. Then what do I do at 1? At 1 the multiplicity is 3, so I have to do it like this, touch and cross. So basically I have to come, and at 1 I have to touch and cross. So that was my only choice, because I can't go up here and then touch and cross, because I'll have to cross before 1. But there's no 0 between -1 and 1. And then finally at 2 it has to cross. So somehow I have to come back down and just straight up cross. And then I have to end up this way, because the end behavior says it's going down this way. So I have a local max here, a local min here, and then another local max there. How many turning points do I have? I have 1 here, 2, and then 3. So there's no turning points in here. The function is just straight up increasing. So the turning points are 1, 2, and 3. So the degree of this is at least 4. Well, we know that it's at least 6. We know that it is actually 6. All right. What if we were not given the function already factored? So you have to factor it first. So how we're going to do this? So this is a degree 3. And then leading term is x cubed. Alright, so let's factor this. So how we're going to factor this? We're going to factor by grouping. So I'm going to factor what I can from the first 2 and factor what I can for the next 2. So this is going to be, I can factor an x squared. What do I have left from the first? Well, x cubed divided by x squared is just x, and then 5x squared divided by x squared is plus 5. And then what can I factor between -4x and -20? I can factor a -4. What's left? Well, -4x divided by -4 is just x, and then -20 divided by -4 is positive 5. So now I can factor something between these two terms. What do they have in common? Well, this x plus 5. So f of x equals x plus 5. And then what's left from this first term? Well, x squared. What's left from the second term? Minus 4. Furthermore, x squared minus 4 is x minus 2, x plus 2. So now that I wrote it, zeros, in factored form, I can say that the zeros are x equals -5, x equals 2, and x equals -2. They all have multiplicity 1, so that means it's straight up going to cross at all of these x's. So the leading term is x cubed, so the end behavior is just like x cubed, and x cubed means it's coming from down below here and it's going to end up here. So I can write this in behavior like that: come from down below here and end here. So as x goes to infinity, the graph goes up to infinity, so y goes to infinity. And as x goes to negative infinity, the graph goes down to negative infinity. Okay, so now we have all the information needed to graph it. So the end behavior is it falls on the left, this is another, and it rises on the right. So it starts here, and it's going to end up here. And in here, what is it doing in here? What are my zeros? -5, so let's say -5 is here, and then -2 is here, and then +2 is here. All right, so I have to start here, and at -5 I have to straight cross, so just straight up cross. All right, and then at -2 I also have to cross, so I have to come back down and straight up cross. No touch, no touch and go. And then I have to come back and cross at 2, and then that's it. So, and then I have to go all the way up. So I can erase this. So this is my function. This is my polynomial. It has my 3 zeros with multiplicity 1, and it has the end behavior of x cubed. All right, one more. We are given the graph of a polynomial. Answer the following. What are the x-intercepts? So what are the x-intercepts? It looks like it's happening at -3 and then at 2. So this is still an intercept, but it doesn't cross. So at 2, the multiplicity is actually even, right? And then 2, 3, 4, 5, 6, and then at 6. Is the leading coefficient positive or negative? Well, since they're both going up, so the leading coefficient of them going both up is a positive leading coefficient. And we also know that the degree has to be an even number, because when the degree is odd, they don't go both together up or together down. What is the minimum degree of f? Well, how many turning points it has? It has 1, 2, 3. So 3 turning points. So the minimum degree is 4. Can I write a possible formula? So this is not going to be an exact formula. Just a possible formula for this will be f of x equals, since it straight up crosses at -3, so it's just going to be x plus 3 with 1 multiplicity. At 2, I'm going to have x minus 2, but it has to have even multiplicity, so let's say 2. And then at 6, it straight up crosses, so x minus 6 with degree 1. So, but this is not exact. We could get it exact by following other points and letting the leading coefficient be a certain value and then solve for it. But this is good enough for our point right now. Alright, so this is it for polynomial functions. You guys will practice in the homework. So the only new thing compared to college algebra is this end behavior that we actually talked in college algebra about for power functions. And then the zeros having odd or even multiplicity and how to get the graph without the calculator.